Well, hello, welcome to our decimal operations test review. Let's get ourselves ready. We're going to pay attention to place value and decimals and where they go and where they should be in your answer. That's kind of the big deal about this whole thing. So why don't you go ahead and take off your sombrero and put on your swim cap and let's go to work. How I encourage people to do this is to print off these slides and then work it as we go together. And then you can pause me where needed or fast forward me because this could be a long review. So I would say go ahead and fast forward me to the answer and then check your answers. And if you have something wonky compared to mine, then maybe watch me solve it and then just look for your misconceptions and tidy it up. All right, I'm gonna go ahead and get to work. So thanks for hanging out with me a little bit here. For adding decimals, you can put either one on the top. It doesn't matter. But what does matter is that you line up your decimals. Okay, so I'm gonna make sure and pay attention that I'm lining up my decimals. And I'm gonna go ahead and do some adding. So 8 plus 7, okay, 15, I'm gotta carry my number over. Okay, 9 plus 3 plus the 1, okay, and that carries over, that's 13. 6 plus 5, okay, plus the 1, okay, so that's gonna be my 12, carry it over. 2 plus 1 plus the 1 is 4. Now, I just drop my decimal down into place, and there's my answer. Nice. So it's lining up the decimals. For this one, again, it doesn't matter which one goes on top. I just have to pay attention that I'm lining up the decimals. All right, I'm gonna go to work. 6 plus 2 is 8, nothing to carry over. 8 plus 5, 13, carry the 1. 1 plus 0 plus the 1 is gonna be 2. 6 plus 3 is 9. I'm going to drop the 1 into place. All right, 9.238. Yay. Now for this one, again, either one can go on the top. I put the longest one on top. Helps me kind of figure things out. And then the bottom one, I got to make sure I line up the decimals. And then I'm going to put in zeros as placeholders. There's only one that's missing a spot. I'm going to add 6 plus 0 is 6. 0 plus 7 is 7, 0 plus 2 is 2, 5 plus 9 is 14, 1 plus 1 is 2, and then I'm going to take the decimal and just drop it into place, 42,276. So for adding, mainly it's carrying over and watching where the decimal goes. Yay. Let's talk about subtraction. Now subtraction, we can't put any one we want in any order we want. The first number has to go on top because it's what we have, and the second number is what we're doing, what we're subtracting. So the key is lining up the decimals for adding and subtracting. Okay, so my second number, I'm just gonna pay attention to where that decimal is, 7, 6, and I'm gonna put in zeros as placeholders in the empty spaces, and now I'm set up to do some subtraction. Gonna have to do some borrowing. So this 0 cannot borrow from this 0 because there's nothing there, but it can borrow from here. So I'm gonna take the 1 and make it a 0 and carry over, so now that's 10. Now there's enough to borrow, so I'm gonna take from the 10 becomes a 9, and now the last digit is a 10. Now I've got enough to do some subtraction. So 10 minus 6 is 4, 9 minus 7, oh, that's good, it's 2, 0 minus 0 is 0, 3 minus 2 is 1, and the decimal just falls into place. Boom, shakalaka. Let's try this one. Top number is what goes first. All right, gonna subtract. Gonna get a 0 in there as a placeholder. Looks like I'm gonna have to do some borrowing. The 2 is gonna become a 1, and the 0 is gonna become 10. So 10 minus 6 is 4. Now 1 minus 8, can't do that, so I'm gonna borrow over here. So that 5 becomes a 4, and that 1 is now an 11 because I'm borrowing 10 of them. 10's coming over. So 11 minus 8 is 3, 4 minus 1 is 3, and my decimal just falls into place. Boom, hope you're getting the hang of this. 8.13 minus 2.716. I'm gonna get a 0 here as a placeholder. And let's subtract. 0 minus 6, can't do it. 3 becomes a 2, bring 10 over. 10 minus 6, that I can do. And then let's do 2 minus 1. I can do that. That's 1. 1 minus 7. Can't do that, so I got to borrow. 8 becomes a 7. Bring 10 over, so now it's 11. 11 minus 7 is 4. 7 minus 2 is 5. Let the decimal just drop into place right there. So 5.414. Boom. All right, find the product. That's multiplying. And some might say, well, where's the x? Where's the 0.72x? Well, when you have a number next to a parenthesis, that means multiplying. So this is what a multiplication problem is going to look like. Now, for multiplying, I can, again, like adding, I can stack them any way I want. But what I'm going to do is I'm going to ignore my decimals and multiply. That's the best way to kind of do this for now. We're going to deal with the decimals last. Okay. Now I have to multiply the 3 to everything. So 3 times 2 is 6. 3 times 7, okay, 21. Perfect. Now this 4 is actually a 40, so I'm going to put a 0 down. Now I'm going to multiply the 4 out. So the 4 times the 2 is the 8, and 4 times 7 is 28, and I'm watching all these place values happening here, and I'm going to add all this stuff together. So this is a 6, this is a 9, 8, 9, 10, carry the 1, the 2 is 3. All right, so I've basically taken the 3 times all this stuff, and I've taken the 4 times all this stuff, and my answer is 3098. But now I need to look for decimal places, like where's my decimal going to go? Well, it has everything to do with how many decimals are in the problem. There's 2 here, and there's 2 here. When I say how many decimals, I'm actually talking about decimal places. So here's 2, and here's 2, a total of 4. So it's going to move 4 places. And there it is. It's right on this guy. Sweet. Ignoring the decimals, and I'm going to do 64 times 9. All those zeros, yep, I don't need them. I'm just going to multiply. 9 times 4, 6. 9 times 6, 54 plus the 3 is 57. Now I'm looking for decimal places. There's 1, there's 2, total of 3. 1, 2, 3. Now, it seems like on all my examples, the decimal is going to go at the very end, and that's not true. The decimal is going to go where it's supposed to go, so it makes you count places. Okay? I'm going to actually ignore the decimals and turn this into 5,342 times 13. Now, because there's 2 digits, there's going to be 2 lines of data here, so just keep track of that. I'm going to do 2 lines of calculations is probably more accurate to say. So 3 times 2 is 6, 3 times 4, that's 12, carry the 1, 3 times 3 is 9, plus the 1 is 10, carry the 1, 3 times 5 is 15, plus the 1 is 16. All right, so I just did the 3. Now I'm going to do the 1, which is actually 10, so that's why I put a 0 down. Now I'm going to run the 1. 1 times 2, 1 times 4, 1 times 3, 1 times 5, and I'm going to add them together, which is 6, 4, 4, 9, 6. All right, let's go look at our original problem and get the place values for the decimals. There's 3, and there's none on that number, so it's got to move 3 total. 1, 2, 3. And there's my answer. Sweet. Sweet beans. Quotient, that's division. All right, so just like subtraction, in division, you can't put it wherever you want. The first number is what you have, so that's going to go in the box, 17.5. And what you are doing to it goes outside the box. All right, for this one, you can have decimals inside the box. You can't have decimals outside. So we don't have any decimals out here, so I'm just going to let it be. The decimal is where it is. I'm going to put it up in the answer, and now the decimal is dealt with, and I'm moving on. So 50 goes into 1 0 times. Now I got to grab the next digit, the 7. 50 goes into 17 0 times. Now I got to grab the next digit. 50 goes into 175 3 times. So 50 times 3 is 150, and I'm going to subtract. 175 minus 50 is 25. Now I have a remainder, so I'm going to tack a 0 on the end and drop it down. 50 goes into 250 5 times, which is 250, and it zeroes out, and I'm all done. So my answer to 17.5 divided by 50 is 0.35. Try another one. Let's try another one, okay? Just keep practicing. You'll get better at this as you just keep practicing it. Okay, 2.16 divided by 0.09. So the first number is what I have. Goes inside the box. Second number is outside the box. Okay, remember, I can have decimals inside the box. I just can't have them out. So on the outside one, I got to move it. So I'm going to move it over 1, but I'm going to do the same here. Move it over 1 and put it up in my answer. So there's now no longer any decimals, or at least the decimals are all cleared out outside the box. So let's start working. 9 goes into 2 how many times? 0 times. 9 goes into 21 2 times, because 9 times 2 is 18. Now I can subtract. 21 minus 18 is 3. Drop down my next digit. And I'm just dropping things down because I'm just chipping away at my answer. 9 goes into 36 4 times. So that is, oh yeah, it's 36. No remainder, it clears out. So my answer is 2.4. What do you want? What was that? What did you say? Kid in the red shirt. Oh yeah. Want to do another one? Okay, let's do another one. That's a great idea. And that red looks good on you. All right, so what I have goes inside the box, that first number. Second number is outside. Oh, got a decimal out there, got to deal with it. Move it over, decimal, decimal. If out here, if I have to move it twice, I got to move it twice in here. If I move it 3 times, I got to move it 3 times inside. They just have to match. Whenever you move one, you got to move the other one. All right, let's go to work on this one. You probably paused it, worked it out, and forward me so you can check out your answer, but that's good. 9 goes into 1 0 times. 9 goes into 11 once. Okay, 11 minus 9 is 2. Drop the next digit down, the 2. Okay, 9 goes into 22 twice. Okay, because that's 18. 22 minus 18 is 4. Let's keep going. There's a 4. 9 goes into 44, so let's see. 9 times 4 is 36. That's as close as I can get. So 44 minus 36 is 8. I have a remainder, so I'm going to tack on a 0 and drop it down, and I'm going to keep going. 9 goes into 8 times, because 9 times 8 is 72. 80 minus is another 8. Oh wow, look what's happening. 0, go down, it's 80. 9 goes into 80 8 times. Look at this is not going to stop. This is going to keep going. Boom, boom, boom. Yikes. So what do I do in that situation? I can do this. I can say the answer to this one is 12.48, and I'm going to put a little bar above the 8, basically saying, hey, this 8 doesn't stop, but I am going to stop doing the math of it. All right, good work on these ones. This is just straightforward, like algorithm stuff, like just clicking through the math. Now let's try this out in a couple of story problems, like situations. So you're trying to determine, do you add, subtract, multiply, or divide? And there's probably decimals involved. So Evanana has a $20 gift card. The table shows the prices of some of the items she's looking at, okay, because she's going to spend some money, because who doesn't love to spend money? How many games could she get with that gift card? Okay, so the games is $2.89. Consider using estimations, so I might say, like, if it's $3 a game. So she's got a $20 card. I'm thinking maybe like 3, 7, 18. So maybe 6 games, because that's like $18, which is really close to 20. So I'm going to do that. I'm going to think of it's probably about 6, but let me try it. So I'm going to take 289, and I want 6 of them. So I'm going to multiply. Right? You see what I'm doing there? I'm trying to change the color here. All right, so 289 times 6. 6 times 9, 4, okay, plus 6 times 8, plus the 5, okay, it's 53. 6 plus 2 is the 12, plus the 5 is 17. Okay, check my decimal places. It's got 2 decimal places, so it's going to do, so 1734. Yeah, that's pretty close. Like, can I get one more? Is 6 enough, or can I get one more game? I'm going to check it. I'm going to add another game on here and see if this is under 20 bucks. So 9 plus 4, 13. 8 plus 3 plus the 1 is the 12. 7 plus 2 is 89 plus the 1. And then the 1, 20. Oh, it's so close. Almost can get 7 games, but only has enough for 6 games. 23 cents off from getting that 7th game. All right, Ava decides to buy one music album and one single song. So let's see. So one music album is $10.49. So $10.49. And let's see. And one single song. Single song is 89 cents. So I'm going to add those up. When I'm adding decimals, I have to make sure I line up the decimals. 9 plus 9 is 18. 8 plus 4 plus 1. Okay. 0 plus 1, 1. Drop the decimal down. So 1138. Okay. So is the question, how much is it gonna? How much is left? How much is left on the card? Ooh. So now I gotta subtract. But I had to add in order to find out how much she spent. So 20 bucks minus 1138. I'm gonna get those zeros as placeholders and let it do some subtraction. Oh wow, a lot of zeros. Okay, 2 becomes a 1, which that becomes 10. I'm gonna borrow, so the 10 becomes a 9, so that becomes a 10. I need to borrow again. This is like a borrow, borrow, borrow. 10 becomes a 9, and I have 10. So now I can subtract. 10 minus 8. 9 minus 3. 9 minus 1. 1 minus 1. Drop the decimal down. She has $8.62 left on the card. How fantastic. Oh, good. Good stuff. Hey, if you need to take a break, like press pause, go have a snack or something like that, go run around your house, go chase the neighbor's dog, whatever you got to do, take a break, and then come on back. Come on back. But don't leave me here hanging out in the pause button. Yeah, don't be doing that. All right, welcome back. Let's get to work here. Let's keep rolling. We're almost done. Number 6, a package of 25 pencils costs $5.75. How much does each pencil cost? It's not going to make sense to add those or subtract those, so I'm either multiplying or I'm dividing. It looks like I am going to be doing some division here because 25 pencils cost this much. So let's divide. I know some people want to use like rate tables or ratio tables and stuff like that. I really want to encourage you to try your division. All right, I have decimals inside the box, which is okay. No decimals outside the box. So I am going to move forward and just pop my decimal up into the answer so I don't have to think about it anymore. Done, done. 25 goes into 5, 0 times. 25 goes into 57 twice. 2 times 25 is 50. Let me subtract. 57 minus 50 is 7. Keep chipping away at the problem, so I'm going to do 75. Oh, 25 goes into 75 3 times, and that just zeroes out. Nice. So, did I answer the question? How much does each pencil cost? 23 cents. Yeah. How many pencils can you buy for $4.80? Well, I guess I could keep doing repeated addition and just keep adding 23 over and over and over again. But probably my best bet is to do division again, is to take $4.80 and seeing how many 23s are in it. Ooh, alert, alert, there's a decimal. There's a decimal out here. We have to deal with it. So let's move our decimal 2 places. And inside we have to do 2 places to match it. Now we can go to work because we've taken care of our decimals. Okay, 23 goes into 4 0 times. 23 goes into 48 twice because 23 times 2 is 46. Subtract, and I've got a 2. I'm going to chop the 0 down here, okay. 23 goes into 20 0 times. Means I got to tack on another 0 and drop it down. 23 goes into 200 like a bunch of times, like not 10 times, because 23 times 10 is 230, so maybe 9 times. Oh, look at, oh, we don't have to go any further. We actually don't have to keep solving this because we found our answer. So how many pencils can you buy for $4.80? It looks like you can buy 20 pencils and like a portion of a pencil. But whole pencils, I can get 20. So we've actually found our answer. We do not need to keep going. Yay. Whew, that was getting long. All right. I'm going to keep going. Don't stop. Keep going. Look it, we're almost done. We're almost done. If you buy an $18 pair of gloves and tax is 6%, find the sales tax. Okay, so 6%. So percent is out of 100. So 6 out of 100, which means this is 600ths. So we need the decimal. Now, when we're doing tax, we're going to have to multiply. So finding tax is always multiplication. And there we go. So 18 times the 6 cents, or 6%, okay? let's multiply that out. 6 times 8 is 48. 6 times 1 is 6, plus the 4, okay, is 10. Let's get our decimal place squared away. It is 2 decimal places, so 1, 2. So it makes sense. It's like $1.08. So I'm going to take $1.08 and add it to $18. Oh, $18 plus $1 is $19, right? And then the 8 cents on the end. So this is how much I'm going to be paying. Boom, shakalaka. Not too bad. Let's talk about 11%. Okay, 11%. 11 out of 100, because percents are always out of 100. And this is going to be 0.11. Percents are multiplying. So it's $65 at the party supply store. So 65 times 11. I like those 1 ones. Those can go pretty quickly. So 1 times 5 is 5. 1 times 6 is 6. This 1 right here is actually a 10, because it's the 1 is in this 10th place. So it says it was 0. So now I can keep going. So 1 times 5 is 5. 1 times 6 is 6. And now I add 5. 6 plus 5, 11. 6 plus 1 is 7. And it's multiplying, so I got to do decimal places. If it was adding, I'd drop it down. If it was subtracting, I'd drop it down. But it's not. It's 2 decimal places. 1, 2. Right there. Let's see if this is reasonable. Is that reasonable? Is 11% $7? Well, 10%, so $65, 10%, you just got to move the decimal over. Boom. So 10% is $6.50. So yeah, $7.50 is a little bit more. Nice. Good job. All right, so now we got to find the total. So I'm going to take that plus the 65. Oh, that's not so bad. So $65 plus the $7 and the 15 cents is going to be like 65, 86, 12, so that's like 12 with the 1, 672, 15, something like that. 32, 15. Nicely done. I might want to check my math on that one again, but I want to keep going though. So Miss Miller, she's getting her hair done. Yeah, she is, and she wants to leave a $15 or 15% tip, not $15, 15%. So 15 is 15 out of 100, which means it is 0.15. So I'm going to do 86 times 15, because when you're finding percent, you are multiplying. Okay. So 8 times 6. No. Stop. Hold the phone. Maybe I need to go get a snack. 5 times 6, 30. 5 times 8 is 40, plus 3 is 43. And now this is not just a 1, but it's a 10, so I got to get a 0 down here. Now I'm going to run the 1. 1 times 6 is 6. 1 times 8 is 8. Let's add those up. 0, 6, 7, 8, 9, 12. All right. Her tip is going to be $1,290. No, it's not. Count the place values. There's 2 here, so 1, 2. So our tip should be around $12.90 to give a 15% tip. Is this the last one? Oh yeah, it's the last one. Yeah! 4 friends want to share the cost of a new set of art pens. Whoa, look at those art pens. They must be super duper amazing. So 234.72. If I'm sharing it with people, like if this is a sharing thing and we're like comparing stuff, that is a division. We're dividing this out. And so we're dividing this out with 4 people. Okay, let's run the math here. 4 goes into 2 0 times. 4 goes into 23 5 times. Because 4 times 5 is 20. 3 left over. Drop down the 4. 4 goes into 34. Gets 8 times. 4 times 8 is 32. Subtract that out. 4 times minus 2 is 2. Gotta go get that 7. Drop that 7 down. 4 goes into 27 6 times. Okay, because 4 times 6 is 24. Let's subtract. 27 minus 24 is 3. Drop the 2 down. 4 goes into 32 evenly. It's like 8. So each person owes $5,868. No, that's not true. We missed the decimal. We just got to pop it up in here. There's my answer. Each person owes $58.68. Hey, thanks for hanging in there for this review. I know it was long, it's a lot of details. A couple things, just really watch place value, watch decimals, practice this stuff over and over again. You get really good at it. I've seen some people like use line paper, you know, like normal like line paper, and you flip it on the end, so then the lines go this way, and it lets you kind of line up all your place values. You can keep track of that, and that helps you. All right, good luck. I am gonna go see if I can grab the neighbor's dog and like shave his tail, because I think that would be hilarious. But I gotta be safe though, because he's a super big dog with really sharp teeth. Actually, maybe I'm not gonna do that. I'm just gonna go eat an ice cream cone. No, not a cone with ice cream in it, just the cone.